Okay, hello. So these questions are paper one from 2022 winter past paper. So I'll be doing them in order. So the first question is a loop of wire lies in a magnetic field directed into the plane of the page. The loop carries a current in a clockwise direction. The magnetic force acting on the wire tends to. Okay, so this question, you have a magnetic field and a current. So you would need to use your right hand rule for a moving charge, a wire in a magnetic field. So you can see on my hand, if I show you this here. So your thumb is the magnetic force is your middle finger, and your index finger is the direction of the current, and then the thumb is the force. So if you can see in uh, the question here, it says the force is the field is directed to the middle of the page. So if you can tilt your finger this way, you can see that your middle finger points towards the page, uh, this way. So if you can see that your magnetic force, the direction is pointing upwards. So if it's pointing upwards, that would suggest that the uh, radius of the loop is increasing. Actually, the option is not mentioned here, but it would be D. If I can just show you here, yeah, this is the same question. So D, increase the radius of the loop, would be correct. Next question. What is correct about the energy changes and the thermal potential difference during the discharge of a practical electric cell? So in terms of energy changes, we know that in the cell is what is stored as chemical energy. So when the circuit is on, the chemical energy will be transferred into electrical energy. So straight away we can eliminate option C and D. In terms of potential difference, we know that uh, in a loop around the circuit, all of the potential energy is used up by the end. The, the current comes back around to the cell. So we could say that it decreases significantly at the time of the end, because it, the amount that is removed at the end is equal to the amount that was started in the beginning. So the option here, the correct answer is B. Next. A cell of negligible internal resistance is connected to three identical resistors. The correct of the cell is 3 amps. The resistors are now arranged in series. What is the new current of the cell? Okay, so we know that the total energy used up, uh, the total potential difference or voltage that is used up throughout the entire circuit will be constant in both cases, regardless of series or parallel. And we know that voltage is equal to IR. So in the first case, as seen on the diagram, the I would be 3. And now the resistance, we have one resistor that's in series and then two in parallel. So to calculate the total resistance in parallel, we do 1 over R plus 1 over R. And then we would flip this around, and then we would add the other resistance. The resistance is all equal. After we add this, we add them in series. So we can multiply all this times 3. So if you do this, you would get 3 times R by 2 plus R. So that would be uh, 3 by 2 times 3R. and that would be equal to, so in the second case, we have the current, which we're trying to find, and the resistance, since it's in parallel, it would be just 3 times the resistance, because you have both the resistors here and then this resistor here, so it would be just VR. So now you can see we can just cancel the R's, we can cancel this 3, cancel this 3. So now the current will be equal to 3 by 2, which is 1.5 1.5 amperes. So it's okay. Last question. Yx and Yy connected in series in a circuit. Yx has 3 times the radius and 1/3 charge carrier density of the wire. What is the drift speed in x over the drift speed in y? So if you go your data booklet to this one, obviously we would have to use this formula here for the current in a wire. So we can assume that the current in both wires is the same. So let's do first for Yx. So we have n A, which is the cross section. Now, if you see a circle, the cross sectional area would be pi r square, right? And then for x in this case, the radius is 3r. So we have pi 3r the whole square, and then the q is divided by 3. It's 1/3 of the in y. So, and then this would be so this pi r square, because in y it's is, oh, I forgot to write yes, and then vy here, the drift speed, and then q. Now you can see you can cancel out the charges, n pi r square, so you're left with 9 by 3 vx is equal to y. So if you rearrange this vy vx, sorry, vx vy is equal to this gets cancelled, this becomes 3. We bring that to the other side, we get 1/3. So the answer is B. Okay, that's it. Thank you.